As someone deeply invested in the discourse surrounding intelligent design, ID, and evolutionary theory, I've spent considerable time examining both the strengths of ID and the criticisms often leveled against it, particularly the claim that it isn't scientific because it's not testable in the way evolutionary theory is purported to be. Let me share why I believe ID holds significant investigative merit and addresses some of the fundamental weaknesses in evolutionary explanations and abiogenesis. Intelligent design as a scientific inquiry. Testability of intelligent design. One of the main critiques I often encounter is that ID is not testable. However, my understanding and study suggest otherwise. ID makes several testable predictions and posits specific hypotheses about the natural world. For instance, ID predicts that we will find instances of irreducible complexity in biological systems, systems that in their functional form could not have been formed by successive, slight modifications. This prediction has been borne out in numerous instances, such as the bacterial flagellum, which requires all of its protein components to function as a rotary motor. Evolutionary theory struggles to account for the step-by-step evolution of such a system where the removal of any component causes the system to cease functioning entirely. Specified complexity. Another strong, testable aspect of ID is the prediction that information-rich structures like DNA will exhibit patterns of specified complexity that are statistically improbable to arise by chance. DNA encodes vast amounts of information with a high degree of specificity and functionality, which in my studies and observations aligns more closely with systems we know from experience are designed. In every realm of human experience, when we encounter coded information, language structures, or purposeful arrangements of parts, we invariably attribute these to the activity of intelligent agents. Fine-tuning. In cosmology, ID posits that the universe's fundamental physical constants are finely tuned for life, which can be empirically evaluated by comparing these constants to a range of life-permitting conditions. This fine-tuning extends beyond what might be expected from random chance, suggesting design. This aspect of ID is not only testable but also opens avenues for further astronomical and physical studies. Addressing the weaknesses of evolution and abiogenesis. Abiogenesis, unanswered questions. Despite decades of research, abiogenesis lacks a viable, testable model for the origin of life from non-life. The spontaneous assembly of life's building blocks into a functioning cell under realistic early Earth conditions has not been observed or replicated in the lab. This gap is critical because if abiogenesis cannot explain the origin of life, the foundation of evolutionary theory on Earth is on uncertain ground. Evolution's struggle with complex systems. Evolutionary theory provides mechanisms such as natural selection and genetic drift for gradual change. However, it faces significant challenges in explaining the origins of complex biochemical systems that appear fully formed in the fossil record. The Cambrian explosion is a prime example, where a plethora of complex organisms appears suddenly without clear evolutionary precursors. Theoretical and empirical gaps. Evolutionary theory often relies on theoretical models that presume the adequacy of natural selection and random mutation to account for all observed biological complexity. However, in my examination, these models often fail to address the empirical gaps, such as the lack of observable transitional forms for the most complex structures and the statistical improbability of forming highly complex proteins by random mutations. In my view, intelligent design not only challenges the conventional narratives of evolutionary biology and abiogenesis, but also enhances our understanding of biological complexities through a framework that considers the possibility of purposeful design. By examining both the strengths of ID and the limitations of traditional evolutionary theories, we can foster a more comprehensive dialogue on the origins and development of life.